Hello dear friends, welcome my channels. Today's discussions is dual vector space. Dual space are very mystical creatures in linear algebras. So if you ever played Legend of Zelda game name, the game name Legend Legend of Zelda. Legend of Zelda, then you know that every world has shadow world. Every world has shadow world. Every world has shadow world. Where it turns out every vector space has a shadow space. Every vector space has shadow space. That space is called dual space. This shadow space has shadow space called dual space. Dual space of V. Every vector space V has shadow space. Dual space. Dual space is the space of linear functional. Space of linear functional. So to define the dual space, you have got to start with a V. Start with a vector space V. V is a vector space and V star the dual space is homomorphisms of V to R. VR. R where R is a field. So regular definitions: V star, so given vector space V, we define V star to just be the set of linear transformation from V to either R or C or any field. So V star can be written this way: L V, F. V star, the dual space, consists of homomorphism V into R. It's just a linear map that start at V and end in R. This dual space is again a vector space. Its given space of linear. This is the vector space of functional. Functionals of the vector space V, just linear functions. Why is V star a vector space? If alpha, beta belongs to V star, then alpha plus beta V is equal to alpha v plus beta v is a linear functional. Alpha belongs to v star and lambda belongs to r, then is a linear functional. Vectors and covectors. Now we discuss vectors and covectors. So friends, vectors in the dual space. Vectors in the dual space, that is covectors. Covectors are just vectors in the dual space. This terminology, covectors, it's a vector and gives you a scalar. So if alpha belongs to v star covector, v belongs to capital V, and alpha comma v belongs to capital R. Just a scalar. Just a scalar. It's the result of applying the linear functional alpha to the vector v, and the important thing to remember is that alpha is not an arbitrary function. Here dimension v is equal to dimension v star. Dimension v is equal to dimension v star. V is such that a finite dimensional vector space, a finite dimensional vector space, and the dimension of the dual space is v star. Dimensional vector space and dimension of the dual space, space v star is v spanned by E1, E2, En, and v star spanned by E upper indices 1, E upper indices 2, E upper indices n. So I have got to define what is this. This is the EI, EJ equals to del IJ equals to summation equals to 1, 0 when I equals to j and when I does not equals to j. E upper indices I. E upper indices I is the linear functional. E upper indices I such that V tends to R projects to the to the ith coordinate. V is not naturally isomorphic to V star. V is not isomorphically V is not naturally isomorphic to V star. V is not naturally isomorphic to V star. An inner product star comma star gives a map. And inner gives a map such that V tends to V star, and defined by F V1 F V2 equals to V1 comma V2. This is linear map. It is a injections. As inner product is positive definite, it is also isomorphic. This is linear map. It's an injection as the inner product is positive definite, and it's also an isomorphism. This is an injection, positive definiteness. This is an isomorphic if dimension V is finite. This is an isomorphic if dimension V is finite. We are talking about row and column vectors or matrices. We have get a peak, a basis, and row and column vectors. After choosing a basis, V belongs to capital V, be written as a column vector with something a matrix. Likewise, alpha belongs to V star. Alpha belongs to V star. Can be written as row vector. So transpose give a map. Transpose gives a map. V tends to V star. Why is this well? It's because you can take a row vector and apply it to a column vector and get a scalar. So in fact, row vectors are linear functionals and column vectors are vectors, and the relationship between row vectors and column vectors is essentially transposes. You can take a column vector and get a row vector by applying transpose. And of course, to do all of this, you have got adjoints of linear map. Adjoints of linear map. Let's start with two vector spaces V and W. V and W, and let F from V to W just some linear map, and we are going to define an adjoint map which goes from the dual space of W to the dual space of V, so it goes in the opposite direction. And that's the important thing to remember about these adjoint maps. Now, how we are going to define this given some are linear. We can define F star such that W star tends to V star, and given alpha belongs to W star, F star alpha comma V equals to alpha F V. Alpha from W to R, so an element of the dual space of W, then it's our job to define F star of alpha is a linear functional on V. So this is an object that is going to take something in V and produced a real number, and we can define it like this. The action of F star of alpha which is linear functional on V and takes vector little v and v, means this is the real number produced. So friends, now we are going to solve a problem based on dual vector space. Now friends, let's try to solve two problems based on dual vector space. Let V equals to Fx belongs to Rx, and degree of Fx less than equals to 1, where R is field of real number. Define where R is field of real number, and define E1 star E2 star such that V tends to R by E1 star Fx equals to 0 to 1 Fx dx, and E2 star Fx is equal to 0 to 2 Fx dx. Then the basis of V, whose dual basis is E1 star and E2 star. So let's start to solve this problem. Solution. Let E1, E2 be the required basis of V given by E1 equals to A plus Bx, and E2 equal to A1 B1x, E2 equal to A2 plus B2x. So friends, you will see that degree of Fx less than equals to 1. So I can choose the base is A1 plus B1x and E2 plus equals to A2 plus B2x. Then 1 equals to E1 star E1 equals to 0 to A1 plus B1 x dx equals to A1 plus half B1 and 0 equals to E1 star E1 equals to 0 to 1 A2 plus B2x dx equal to A1 A2 plus half B2 and 0 equals to E2 star E1 0 comma 0 to 2 A1 plus B1x dx equal to 2A1 plus 2B1. And now we get A1 equals to 2 and A2 equals to minus half and B1 equals to minus 2 and B2 equals to 1. So basis equals to 2 minus 2x minus half plus x. Friends, I just solved this equation, this 3 equation. I get this. I just solve this problem. And another way is E2 star. Another case is applying this problem E2 star E2 equals to 1. So apply this formula. Now let's try to solve another problem, that find the dual of the basis E1 equals to 1 comma minus 1 comma 3, E2 0 comma 1 comma minus 1, E3 0 comma 3 comma 2 of R cube is. So friends, let take the dual basis E1 star xy comma z equals to A1x plus B1y plus C1z, E2 star x comma y comma z equals to B1x, sorry, this is the very A2 and A3 z, this is the proper way, B2y plus B3z, just move A2y plus A3z, and E3 star x comma y comma z equals to C1x plus C2y plus C3z. So friends, I have to solve this problem with the process of dual. Now where A1, B1, C1, where A1, B1, C1 belongs to capital R, are to be determined, determined which will make E1 star E2 star E3 star. So friends, in my theory class, I have told that 1 equals to when E1 star E1 star E1 and E1 star 1 comma minus 1 comma 3, and it can be written this way: A1 minus A2 plus 3A3 and 0 equals to E1 star E2 and E1 star 0 comma 1 comma minus 1 equals to A2 minus A3 and 0 equals to E1 star E1 equals to E1 star 0 comma 3 comma minus 2 3A2 minus 2A3, and I just solve this equation and I will get A1 equals to 0, A1 equals to 1, A2 equals to 0 and A3 equals to 0. You can put this value in here, you can get same factor. And another similarly we can get B1 B2 B3, B1 equals to 7, B2 equals to minus 2, B3 equals to minus 3, and C1 equals to minus 2 and C2 equals to 1 and C3 equals to minus 1. So friends, you can get it easily in this way: E1 star E1, similarly E2 star E1 E2 star E2 is this way. You can find easily this value B1 B2 B3 easily you can get. It is also E3, so my dual basis is x comma 7 x minus 2y minus 3z and minus 2x plus y minus z. So friends, I hope I can clear this concept. I easily dual basis is also like a covariant vectors. So friends, I hope I can clear this concept. Thanks for watching.